Hello everyone. Today we have this nice math before us. Yeah, it's a logarithmic equation from Math Olympiad. How do we solve this challenge? The question reads: solve for x in minus x to the power of 2 equal to 5 ln of x. If we look carefully here, can we use graphical method to solve this? Yeah, we could use graphical method, but I don't like using the graphical method because in case of examination, okay, like Olympiad. So I prefer using the algebraic method or approach to solving questions of this kind. So how do we get the value of x to this challenge here? If you're new here, this is MathProwess, and if you've not subscribed, do it to subscribe so that you get notified whenever I drop an amazing video like the one you're about to watch right now. So without much waste of time, let's take a solution to this challenge and see what this gives us in turn. All right, solution. Now, the first we're going to do here, we want to divide through by x to the power of 2 here. So we have this to be minus x to the power of 2 all over x to the power of 2. This is equal to our 5 ln of x all over x to the power of 2, right? So this leaves, we're going to have this side to be minus 1. And so let's rearrange this equation to give us here our 5 ln of x all over x to the power of 2 equal to minus 1. Oh, so what are we doing next here now? So we look carefully. From here, we want to rewrite the denominator here. We all know that if we have an expression of this kind, you have e to the power of ln of our a. This is equal to a. Why? Because this goes with this. So we are not left with a, right? Okay, so if we are familiar with this, so let's bring e to the power of ln of e to the denominator here. So we can now have this to be our 5 ln of x all over e or to the power of ln of our x all to the power of 2 here, everything equal to minus 1. Now, from this expression we have here, we know the law of logarithm, which says that if you have your log, let's take p to the power of m, then move this exponent backward here to give us here our m into log p. We all know this law, right? So if we apply this law, then we can move this exponent here down to the side here. So let's go ahead and do that. This will now give us a 5 ln of x all over our e all to the power of 2 the ln of our x here. Everything equal to minus 1. Here we want to remove this division sign here. Okay, we all know that from the law of indices says that if we have 1 all over a to the power of m, this is equal to our a to the power of minus m. We know this very law, right? So we can equally apply that to this expression we have in here. So this will now give us here our 5, the ln of x times our e. What is our exponent? The whole of this is our exponent. So this is going to give us minus 2 ln of x. This is equal to minus 1. Wow, we're heading somewhere. Now, with what we have here now, what comes to mind is what we call the product log or the Lambert Wn function. What does it say? It says that if you have your a the times your e all to the power of a, and we take the Lambert Wn function, this will give us our a. Remember this? This is called the product log or the Lambert Wn function. But on what condition will this work out? The base here must be equal or must be same with the exponent we have here. Now let's come to our expressions we have here. Here we are having minus 2 ln of x, and here we are having 5 ln of x. So there's a difference here, and there is no number we can use to divide this 5 here to give us 2 and then multiply by minus 1. So what we do here, it is easy. We have to eliminate this 5 first. So let's divide through by 5. We divide this side by 5 also. So this leaves the system. So once this leaves, we think of introducing minus 2 to both sides of the equation. So we multiply by minus 2. So this will give us minus 2 to the ln of x times our or to the power of minus 2 ln of x. This is equal to minus 1 all over 5 times minus 2. Okay, of course, this minus, we go with this minus. We all know that, right? So this now give us minus 2 ln of x times our to the power of 2 ln of x equal to our positive 2 all over 5. Now, what can you spot out from the left-hand side of the equation? What we have here now is same thing we now have here. So our product log or Lambert Wn function can come into play. So let's introduce our Lambert Wn function. So this is going to give us our Wn there into minus our 2 ln of x then times our to the power of minus 2 ln of x close bracket. This is equal to, we do same thing here, the Lambert Wn function into our 2 all over 5 bracket. So what happened, we're going to end up having this, or this now implies our minus 2 ln of x. This is equal to the Wn function of our 2 all over 5. Easy. Now again, we're looking for x. So the easiest way to get our x here is to eliminate minus 2. So let's divide both sides by minus 2. Then we equally divide this by minus 2. So this leaves the system. So we end up having our ln of x, right? So we have ln of x is equal to minus the Lambert Wn function of our 2 all over 5 close bracket all over 2. Oh, so how do we get our x here? Now, remember the expression or the equation we look at the other time. What we look at here, look at this. We said e to the power of ln of a will give us a. So we can introduce e to this system here. Okay, so let's go ahead and introduce e to this system. So this now implies our e to the power of ln of x. This is equal to, we do same thing here, e to the power of minus wn the 2 all over 5, yeah, everything all over 2. So what happened, this leaves the system to give us here our x will now be equal to e to the power of the Lambert n Wn function all over 5 all over there 2 here. So this is the value of our x here. Now in this solution or in this answer, we have infinite solution to our x here because of n. N is a set of numbers ranging from 0, 1, 2, 3. Okay, so we say where n is equal to 0, 1, 2, 3, comma, dash. So we can get infinite solution to this expression here by substituting our n to be 0, put 0 here, and using the Wolfram Mapper calculator, we can get all solutions to this x. Okay, so this brings us to the end of this. If you've learned something from this video tutorial, give the video a thumbs up. And if you're not clear in any of the steps, then drop it in the comment section. We'll respond to your comments. Thanks for being there for MathProwess. Bye.